Hello students. In last lecture we discussed introduction to enterprise information system and this was the structure. We have covered all these topics in our last lecture. So today we are going to discuss a case study on EMI on a case so today we are going to discuss a case study on EIS. Basically, there are two case studies. First is HP's global spare parts business integration, and second is Rolls-Royce ERP implementation. So, we are going to study these two case study together. So, let's start with the case studies. EIS are critical for the efficient management of business processes and resources. This case study explores the implementation of EIS in two large organizations, HP and RR. We are going to say RR to Rolls-Royce and examines the challenges, strategies, and outcomes associated with these implementation. The case studies of HP and Rolls-Royce highlight the complexity and benefits of implementing enterprise information system by addressing integration challenges, leveraging custom software, and fostering collaboration. Both organizations achieved significant improvements in efficiency and decision making. These insights provide valuable lessons for other organizations embarking on similar EIS implementation. So here are the questions for these two case study. You can take the screenshot and try to find out the answers of all these questions. Although we will going to discuss these 10 questions one by one. First question is, what challenges did HP and Rolls-Royce encounter during the implementation? So first question is, what challenges did HP and Rolls-Royce encounter during the implementation of their enterprise information system? So HP's challenges during EIS implementation. First is integration complexity. So HP faced the daunting task of integrating disparate regional systems into a cohesive global system. Each region had developed its own processes and IT solutions over time, leading to a patchwork of systems that were not designed to communicate with each other. The complexity was further compounded by the sheer scale of HP's operations, which included thousands of professionals across multiple continents. Next point is data consistency and accuracy. With the integration of regional systems, HP had to ensure that data remained consistent and accurate across the board. This was particularly challenging given the different data formats, standards, and quality levels that existed across the various regional systems. Ensuring that integrity was crucial for HP to maintain operational efficiency and make informed business decisions. Next point is change management. The implementation of a new EIS often requires significant changes to existing business processes and workflows. HP had to manage the change process carefully to minimize disruption and resistance from employees who were accustomed to the old systems. Effective communication and training were necessary to ensure a smooth transition. Next point is customization versus standardization. HP needs to strike a balance between customizing the system to meet specific regional needs and standardizing processes to achieve global efficiency. Over customization could lead to a complex and unwieldy system, while excessive standardization could ignore local market dynamics and business practices. If we talk about Rolls Royce challenges during EIS implementation, so first point is cultural resistance. RR implementation of an ERP system required a cultural shift within the organization. Employees had to adapt to new ways of working, which often met with resistance. The company needed to manage this cultural change by addressing concerns, providing adequate training, and demonstrating the benefits of the new system. Next point is technical integration. Rolls Royce had to ensure that the new ERP systems integrated seamlessly with existing technologies. This included legacy systems that were critical to ongoing operations. The technical integration had to be executed without causing significant downtime or data loss, which required meticulous planning and execution. Next point is business process reengineering. The ERP implementation was not just a technological change but also a business transformation. RR had to re engineer its business processes to align with the capabilities of the new system. This often involved rethinking and redesigning workflows, which could be a complex and time consuming processes. Next point is managing expectations. With any large scale IT project, managing stakeholders' expectations is critical. RR had to ensure that the project's scope, timeline, and budget were clearly communicated and that stakeholders had realistic expectations about the outcome and benefits of the ERP system. Next point is training and user adoption. A new EIS requires users to learn new skills and adapt to new interfaces and procedures. RR faced the challenges of training its workforce to use the ERP system effectively. Ensuring high user adoption rates was essential for the system to deliver the intended benefits. And the last point is balancing tangible and intangible benefits. While the ERP system promised several tangible benefits such as cost savings and efficiency gains, RR also had to consider intangible benefits like improved employee morale and customer satisfaction. Balancing these different types of benefits and demonstrating the overall value of the system was a key challenge. In conclusion, both HP and RR encountered significant challenges during the implementation of their enterprise information systems. These challenges ranged addressing these head on with strategic planning, effective communication, and comprehensive training programs. Both companies were able to successfully implement their EIS and realize substantial benefit from their systems. Our next question is, how did HP and RR address the complexities of integrating their EIS with existing processes and technologies? First, we will discuss HP's approach. So, deployment of updated enterprise software, HP undertook a significant project to integrate its global spare parts business by deploying updated SAP and other enterprise software. This move was aimed at streamlining business processes and supporting a multi-billionaire dollar business. The updated software provided a unified platform that could handle the complexities of global operations, ensuring that different regional systems could communicate effectively and share data seamlessly. Second point is development of custom software to address specific needs that could not be met by off the shelf solutions. HP developed custom software such as GCSN and GCSS. These custom solutions were integrated with SAP modules to automate spare parts management process globally. This approach allowed HP to tailor the system to its unique requirements while leveraging the robust capabilities of SAP for core functionalities. Next is careful change management. HP managed the change process carefully to minimize disruption and relevant. Careful change management, HP managed the change process carefully to minimize disruption and resistance from employees who were accustomed to the old systems. This involved extensive training programs, clear communication about the benefits of the new system, and phased implementation to allow users to adapt gradually. By addressing the human aspect of the integration, HP ensures smoother adoption and reduce the risk of operational hiccups. Next is balancing customization and standardization. HP needed to strike a balance between customizing the system to meet specific regional needs and standardizing processes to achieve global efficiency. This balance was crucial to ensure that the system was flexible enough to handle local variations while maintaining a consistent global framework. By carefully evaluating the needs of different regions and finding common ground, HP was able to create a system that was both efficient and adaptable. Now we will talk about RR approaches, partnership with IFS for AI and predictive maintenance. RR partnered with IFS to leverage their combined AI expertise for predictive maintenance on engines in the field. This partnership resulted in the development of a new analytics maintenance model that could be applied to aftermarket maintenance in various industries and factory assets. The collaboration enabled RR to integrate advanced AI capabilities into their existing processes, enhancing their ability to predict and manage maintenance needs. Next point is automated data pipeline to streamline data collection and improve accuracy. RR approached IFS to automate the data flow from customers. These resulted in the creation of an automated data pipeline that provides real time or near real time in service status of assets. The automated pipeline reduced the time and effort required for data collection, ensuring that accurate and up to date information was always available for decision making. Next point is Intelligent Engine Digital Twin Program in 2018. RR initiated the Intelligent Engine Digital Twin Program to predict real time component uses and lifetime using AI modeling. This program required continuous and accurate access to data on engine use, which was facilitated by the automated data pipelines and the integration of sensor data. The digital twin program allowed Rolls-Royce to create connected and contextual aware engines, enhancing their ability to manage and maintain their assets effectively. Another point is Rolls-Royce Data Labs and Data Innovation Cells RR established R Square Data Labs, focusing on machine learning, AI, and data analytics to create new services. The company also formed data innovation cells to work with team across the operations using DevOps principles to explore data and test new ideas. This rise to this approach enabled rapid iteration and collaboration with customers, allowing Rolls-Royce to identify business opportunities and release proof of concepts quickly. The R Square Data Labs team delivered significant value through engine health monitoring activities, demonstrating the effectiveness of integrating advanced data analytics into existing processes. And our last point is virtual validation with IC1DO. Rolls-Royce engineers used ICIDO to virtually validate human centric operations, allowing lifelike exploration and task validation. This virtual reality software enabled organizing the engineering review that uncovered integration challenges faced with cross functional collaboration, allowing for product and process optimization much earlier in the development phase. By identifying and addressing potential issues early, RR was able to streamline the integration of new technologies with existing processes. So, both HP and Rolls Royce addressed the complexities of integrating their EIS with existing processes and technologies through a combination of updated enterprise software, custom solutions, strategic partners, automated data pipelines, advanced analytics, and careful change management. These approaches allowed them to enhance operational efficiency, improve data accuracy, and ensure seamless integration across their global operations. So, our third question is, what strategies did HP and Rolls Royce employed to ensure the effectiveness and relevance of their EIS in supporting business operations? So, first we will discuss HP strategies. First strategy is incremental modernization. HP implemented changes in manageable phases to reduce operational disruptions and allow for adjustments based on early feedback. This approach ensured that the EIS could be updated and improved continuously without causing significant downtime or operational issues. Second strategy is modular upgrades. By focusing on modular components that could be upgraded individually, HP facilitated easier integration and testing. This strategy allowed for specific parts of the EIS to be enhanced without overhauling the entire system, ensuring ongoing relevance and effectiveness. Third strategy is continuous integration and continuous deployment. HP adopts these CI and CD practices to automate the deployment of updates. This approach ensured a smooth transition and reduced the likelihood of errors, maintaining the system's effectiveness and relevance over time. Next strategy is middleware solutions. HP chose middleware solutions that could handle the specific requirements of their legacy systems while supporting modern communication protocols. This strategy minimized disruptions and optimized data flow between systems, ensuring seamless integration and communication. Next strategy is cloud integration. HP utilized cloud service to dynamically adjust resources to meet changing demands without needing physical infrastructure upgrades. This approach leveraged high performance computing capabilities to improve application responsiveness and efficiency, keeping the EIS relevant and effective. Last strategy is training and skill development. HP ensured that their IT staff had the knowledge and skills to manage and integrate new technologies with legacy system. Establishing a continuous learning culture helped the company keep pace with technological advancements and maintain the effectiveness of their EIS. Now we will discuss the strategies of Rolls-Royce. First is multi-vendor IT strategy. RR employed a multi-vendor IT strategy to create an industry leading multi-vendor IT ecosystem. This approach provided flexibility and resilience, ensuring that the EIS could support the company's current and future global business priorities. Second strategy is outsourced off-premise solution RR opted for outsourced off-premise solution to provide data center facilities worldwide. This decision allowed for proactive management services to improve availability, achieve flexibility, and keep the IT portfolio up to date. Third is service oriented architecture called SOA. RR encapsulated legacy functionalities into service that modern applications could easily consume, hiding the underlying complexity. This strategy enhanced the ability of different systems to work together and facilitated the reuse of existing functionalities across different applications and systems. Fourth strategy is legacy wrapping. So, RR maintained the core functionality of legacy systems while providing a pathway for integration with modern applications. This approach simplified the interface with which new systems interacted with legacy systems, minimizing the need for extensive changes and enhancing the longevity and usefulness of current systems. Fifth strategy is data migration and integrity. Rolls-Royce developed a detailed migration plan to minimize downtime and ensure data integrity. Comprehensive validation and testing procedures were implemented to ensure that migrated data was accurate and complete, maintaining the effectiveness of the EIS. So both HP and RR employed a range of strategies to ensure the effectiveness and relevance of their EIS in supporting business operations. Our next question is, how did HP and RR address the challenges of adapting to technological advancement and evolving industry standards while maintaining their EIS? So, first we will discuss HP's strategies. HP was contracted by RR to migrate and modernize their disparate technology cluster within existing data centers. This involved moving to a pair of world class, modern, highly resilient, and secure HP data centers. By upgrading the data center infrastructure, HP ensured that their EIS could support the latest technological advancements and meet evolving industry standards. Second strategy is leveraging external expertise. HP recognizes that they did not have the in house expertise required to deliver certain technology silos on the program. To address this, they sought external assistance to ensure they met key deadlines and maintained the effectiveness of their EIS. This approach allowed HP to incorporate specialized knowledge and skills, ensuring that their systems remained up to date with the latest technological advancements. Next strategy is collaborative design and implementation. So HP worked closely with the RR project managers and the RR architecture review group of design solutions that met new architectural standards. This collaborative approach ensured that the EIS was aligned with the latest industry standards and technological advancements, making this system more robust and future proof. Last strategy is rapid deployment and cost efficiency. HP's team delivered some of the first key phases of the data center migration within 7 weeks, significantly ahead of the suggested 7 months timescale. This rapid deployment not only saved the end client an estimated $1 million but also demonstrated HP's ability to adapt quickly to technological changes and maintain the relevance of their EIS. Now we will discuss Rolls-Royce strategies. First is pioneering electrification. RR has a long history of pioneering electrification dating back to the early 90s. The company has committed to introducing an all electric car within the current decade, ensuring that their EIS supports the latest advancements in electric vehicle technology. This commitment to electrification demonstrates RR proactive approach to adapting to technology advancements. Second strategy is integration of AI and machine learning. RR has integrated artificial intelligence and machine learning into its operations through initiatives like the Intelligence Engine. This initiative uses AI to create digital twins of physical engines, enabling predictive maintenance and reducing unplanned downtime. By incorporating AI, RR ensures that the EIS remains at the cutting edge of technological advancement. Next is establishing R Square Factory. In 2017, RR established R Square Factory to manage their digital transformation. This factory helps major global corporates and industrial entities to build new technology solutions powered by AI and machine learning. This initiative ensures that RR's EIS can adapt to technological advancements and evolving industry standards by fostering a culture of continuous innovation and digital transformation. Next strategy is focus on sustainability and ethics. R Square Factory also focuses on sustainability initiatives such as net zero initiatives and supply chain intelligence. Additionally, they have opened the Alethea framework, a toolkit for ethics and trustworthiness in AI, which is freely available for everyone to use. This focus on sustainability and ethical AI ensures that RR's EIS aligns with evolving industry standards and societal expectations. Our next question is, what specific improvements in accuracy, productivity, and reporting were observed after the implementation of the EIS at HP and RR? Let's look at the case study of HP. First improvement was streamlined business processes. The deployment of updated SAP and other enterprise software allowed HP to streamline its business processes, supporting a multi-billion dollar business. This streamlining led to significant improvement in productivity by ensuring that operations were more efficient and less prone to errors. Second is enhanced spare parts management. HP developed custom software such as GCSN and GCSS, which were integrated with SAP module to automate spare parts management process globally. Third is advanced data visualization and analysis. HP utilized sophisticated computer techniques to visualize and manipulate massive data sets generated during the design process. This capability was crucial for decreasing development time, improving product quality, and enhancing overall performance. The ability to analyze large volume of data accurately allowed HP to make more informed decisions, thereby improving productivity and reporting accuracy. Next is rapid deployment and cost efficiency. HP team delivered key phases of the data center migration significantly ahead of the suggested timescale, saving the end client an estimated 1 million euro. This rapid deployment demonstrated improved productivity and cost efficiency, showcasing HP's ability to adapt quickly and efficiently to new systems. So, RR improvements is improved predictive maintenance. The intelligent engine digital twin program allowed Rolls-Royce to predict real-time component uses and lifetime with AI modeling. This capability ensured more accurate maintenance, prediction, and scheduling, reducing unplanned downtime and improving overall maintenance accuracy. Second is real time data accuracy. The automated data pipeline from customer into RR provided real time or near real time in service status of assets. Third is enhanced reporting and decision making. The ERP implementation at Rolls-Royce required all business reports to be justified, leading to improved reporting capabilities. The system allowed for the identification, validation, cleaning, loading, and archiving of data, enhancing the quality of information available for decision making. This systematic approach ensured that reports were accurate and reliable, supporting better business decisions. Fourth point is increased productivity through automation. Business processes at RR were automated, including CRM, order generation, and fulfillment. This automation led to enhanced productivity by reducing the time and efforts required to complete these tasks and ensuring that they were performed consistently and accurately. Next point is streamlined operations. The phased implementation strategy at RR involved replacing 1500 old systems with the new ones, leading to streamlined operations and improved efficiency. This systematic approach ensured that the transition was smooth and that the new systems were fully integrated into the existing operations, contributing to overall productivity improvements. Next is contextual data for asset uses. IFS provided all configuration and contextual data regarding the life limited components on the engine integrated with sensor data and other information. This integration allowed RR to evaluate engine condition and the true remaining life of the asset more accurately, leading to more precise maintenance needs and improved asset management. So, all in all, both HP and RR observed significant improvements in accuracy, productivity, and reporting after the implementation of their EIS. HP's improvements were driven by streamlined business processes, enhanced spare parts management, advanced data visualization, and rapid deployment, whereas RR improvements were achieved through enhanced predictive maintenance, real time data accuracy, improved reporting and decision making, increased productivity through automation, streamlined operations, and better contextual data for asset uses. Our sixth question is, how did the EIS enhance collaboration and communication across different departments within HP and Rolls-Royce? So, first we will discuss HP's EIS enhancements in collaboration and communication. First point is unified platform. HP's integration of global spare parts business into a unified SAP platform allowed for seamless communication between departments. This means that information from sales, supply chain, and customer service could be easily accessed and shared, fostering better collaboration. Second point is real time data sharing. With the EIS in place, HP departments could access real time data, which is crucial for making timely decisions. This immediate this immediacy in communication helps in aligning various departments with the company's operational goals and strategies. Third point is custom solutions for specific needs. HP's development of custom software solutions integrated with SAP modules allowed for tailored communication flows that met the specific needs of different departments, ensuring that all parts of the business were aligned and could communicate effectively. Last point is centralized information repository. A centralized database within the EIS provided a single source of truth for HP employees. This reduced miscommunication and errors that can occur when multiple versions of documents are being selected and dataset exist across an organization. Now we will discuss Rolls-Royce EIS enhancements. First is digital twin technology. RR Intelligent Engine Initiative, which uses AI to create digital twins of physical engines, allowed for better collaboration between design, manufacturing, and maintenance teams. Each department could access the same model and understand the implications of their decisions on other areas. Second point is IoT and connected systems. The networking of manufacturing execution systems and the use of IoT within factories meant that data from the production line could be instantly communicated to other relevant departments such as inventory management and procurement, optimizing the supply chain and production schedules. Next point is performance based agreements. RR's performance based service agreements like Total Care required close collaboration between service teams and customers. The EIS facilitated this by providing platforms for sharing performance data and coordinating maintenance activities. Next is data driven services centers, which service centers analyzing data from engines globally. Communication between field service representatives and central engineering teams was critical. The EIS enabled the sharing of insights and recommendations quickly and efficiently. Rolls-Royce's adoption of collaborative and outcome-based business models necessitated a high level of correlation or coordination across the company. The EIS supported this by enabling different departments to work together towards common goals and outcomes. Next point is training and upskilling initiatives. Both companies likely used their EIS for training and development purposes, ensuring that employees across departments had the necessary skills to use this system effectively and communicate through it. Our seventh question is, what factors influenced HP and Rolls Royce's decision in choosing specific types of EIS? For example, on premises, cloud based, and industry specific. So, HP's decision factors are need for modernization and integration. Second is expertise and external assistant. Third is rapid deployment and cost efficiency. And for Rolls Royce, the decision factors are multi vendor IT strategies, outsourced off premise solution, legacy system challenges, overcoming cultural and technical challenges, improved information and supply chain integration. So, we have already discussed all these points in previous questions. So, both HP and Rolls Royce made strategic decisions in choosing specific types of EIS based on their unique needs and challenges. HP focused on modernization, integration, and rapid deployment, while RR emphasized a multi vendor IT strategy, outsourcing, and overcoming legacy system challenges. These decisions were influenced by the need of flexibility, expertise, cost efficiency, and improved information and supply chain integration. By addressing these factors, both companies ensured that their EIS solutions were aligned with their business priorities and capable of supporting future growth and technological advancements. Next question is, how did HP and Rolls-Royce ensure that the selected EIC aligned with their unique business processes and scalability requirements? As we discussed in previous question, HP's approaches and RR approaches, you can copy that answer in this question. Also, I'm including, I'm mentioning the headings of the answer. First approach from HP side is custom software development. Second point is unified platform for real time data sharing. Third is rapid deployment and cost efficiency. And last is expertise and external assistance. You can note down the approaches of Rolls-Royce. First point, simplified management system with BIC platforms. Second is process standardization and scalability. Third, integrated and user-friendly management system. Fourth, efficient corporate management and compliance security. Fifth, process oriented compliance management. And last is streamlined business processes and rapid deployment. We have covered these points in our previous answers. So, both HP and Rolls Royce took strategic steps to ensure that their selected EIS aligned with their unique business processes and scalability requirements. HP focused on custom software development, unified platforms, etc. Other side, Rolls-Royce emphasized simplified management system, process standardization, and so on. And our next question is, what were the key lessons learned from the EIS implementation and maintenance process at HP and Rolls-Royce? So, the implementation and maintenance of an enterprise information system in large organizations like HP and Rolls-Royce offer valuable lessons that can be beneficial for other companies considering similar initiatives. Here are some key lessons learned from their experiences. So from HP side, first point is importance of customization. HP's development of custom software solutions integrated with SAP modules highlighted the importance of tailoring the EIS to fit specific business processes and needs. Customization can lead to better user adoption and more efficient operations. Second is need for expertise. HP decision to seek external assistance for areas where it lacked in-house expertise underscores the value of leveraging specialized knowledge for complex EIS implementation. Third point is rapid deployment and flexibility. And last point is scalability consideration. Rolls-Royce lessons learned. First is simplification and standardization. RR's replacement of a complex quality management system with a more simplified and integrated EIS emphasized the need for simplification and standardization in EIS design. This can reduce training time, increase user adoption, and facilitate easier maintenance. Second point is compliance and regulatory considerations. Third is user friendly design. Fourth point is continuous improvement and feedback. Next point is cross functional collaboration, change management, and last we have monitoring and maintenance. And our last question is, what recommendation would HP and Rolls-Royce provide to other organizations considering the adoption of an EIS based on their experience and outcomes? So, first point is leverage external expertise. Second is strategic outsourcing. Third is ensure alignment with business processes and scalability. In first point, leverage external expertise, we have incorporate external knowledge. That means organizations should incorporate external expertise to complement internal knowledge and enhance decision making processes. Engaging with experts from various fields, including academics, C level executives, and subject matter experts, can provide punctuated insights and reduce uncertainty. Second is set clear criteria for expert management. Set clear criteria for identifying and accessing experts, considering factors such as their involvement in past subjects, meta topics, reputation, and career path. Utilization professional social networks like LinkedIn for reaching out to engineers or scientists, and engage third party services providers for addressing C level executives or thought leaders. Next point is engage experts effectively. And last is quality control and fact checking. In our second heading, which is strategic outsourcing, there are more 4 points like leverage specified expertise. First point is leverage specialized expertise. Second, enhance operational efficiency. Third, flexibility and scalability. And last, risk management. And in our third point, ensure alignment with business processes and scalability. There are another 5 subheadings. First is customization and integration. Second, unified platforms for real time data sharing. Third, simplification and standardization. Fourth, user friendly design. And last, continuous improvement and feedbacks. So, HP and Rolls Royce experience with EIS implementation and maintenance provide valuable insights for other organizations. By leveraging external expertise, engaging in strategic outsourcing, and ensuring alignments with business processes and scalability requirements, organization can enhance their decision making process, optimize resource allocation, and achieve a successful EIS deployment. These recommendations can guide companies to not only implement an effective EIS but also ensure its long term benefits and adaptability to future growth and technological advancements. Hope you have understood all the questions. You can take the screenshot and find out the answers on your own. If you feel any doubt, you can connect with me on these details.